All right, welcome back everyone. I just wanted to do kind of a quick follow-up to the previous video, just with a couple extra tips and kind of things I've found helpful when completing these types of questions, and a little bit more complex questions as we see. Now really, this question here, there isn't really much different to what we have seen before in the past video. Really the only difference is that now that mirror itself is not straight up and down. It's now just on a slight bit of an angle. So really, there's not much different about the process at all here. Really, the only thing that has changed is the fact that with that angled mirror, we are going to have to make a slight alteration. Oftentimes, what I will see students do with this type of question is when they are measuring the distance from the object to the mirror, they typically just measure directly straight across from that mirror itself. However, when we are looking at this, we do have to account for the fact that that mirror is on an angle. So with that being said, you are going to still have to make sure that you have that perpendicular line measuring off of the mirror to make sure that it is exactly 90 degrees. If not, you might get something that says it is 5.3 centimeters. But really when we catch the perpendicular to that, you're actually going to see that it's only about 5.1 centimeters away. So looking at that, you may not see that as a big issue. However, it will dramatically alter the actual ray diagram itself. So solving this question, right, exact same thing as we did before. We need to figure out the distance from the object to the mirror. But remember, we have to do this completely perpendicular to the mirror itself. Now, when we get here, right, I do have quite a large protractor. What you're going to notice is that the protractor is outside the span of the object that we're looking at. And that's going to be pretty hard for us to get that perfect 90-degree angle from that mirror. So one thing that you can use, and I do use this quite frequently, if you do notice that you can't get 90 degrees off the mirror like that, what you can actually do is you can flip your protractor over and you can take this line here as well as the 90-degree line, and you can actually line those up with the mirror. Now, when you do that, this bottom edge of your protractor is also going to represent 90 degrees off of that mirror itself. So sometimes just a nice little tip to have so that you can do this a little bit easier. So when I flip that over, right, I'm just going to line that up again, finding that 90 degree off of my mirror itself. All right, I'm just going to draw that dotted line back to my object and continue that further beyond the mirror. Now, when I do that, all right, now I can actually use my ruler. I can measure straight along that line from the object to the mirror itself, and I will see that I have about 5.2 centimeters from the object to the mirror. Now, as we know, right, if we are looking at a mirror, right, the perceived image of the object is going to be the exact same distance behind the mirror or on the virtual side of the mirror as it is in front of the mirror or in the real world. So here I'm going to take my ruler again, placing my 0 right along the mirror itself, and I'm going to measure 5.2 centimeters beyond the mirror. Right? And that is going to give me my location of my virtual object. That is 5.2 centimeters, right? And my virtual object is going to be right there. Now with this, right, nothing else changes with our overall process. We are going to go through, again, starting with our reflected ray, right? Starting off at the point itself, right in the middle of the point, running from there to the middle of the eye. Remember, behind the mirror, always dotted lines, right? Make sure that you're not making that mistake. Once we get in front of the mirror, it is a nice solid line back to the middle of the eye. Again, don't forget, always put that little arrow on there showing that that is our reflected ray. Now, using that reflected ray, I can then bounce that back to figure out where my incident ray is. Again, you are starting right here at the location where that reflected ray is coming out of the front of the mirror. I'm going to take my pen, right? Run that right back to your object and a nice straight line. Again, remember, always use rulers. Right? This is coming down in this direction because the light is coming from that object into the mirror, right? This is our incident ray. Now, coming up next, right, as we have done before, we are going to come up with our normal. Again, I'm just going to show you that kind of other trick that we can do right here, right? You're going to try and do it. Well, we're not really going to be able to see a point where that mirror intersects the 90 degree. We could extend our mirror a little bit further on, but in this situation, it's not really going to work for us. So I'm going to flip it down to the traditional way that we have been doing it before. Again, placing my point right at the point where those two things are going to intersect, right? I am lining up my 0 degree line along with the mirror itself, and I'm making my little mark at 90 degrees, right? This is so that we can form our normal. Take my ruler back to the point where these two are going to intersect at the mirror. Gonna run that right back over to that mark I just made, and we are going to see that this here is our normal. Right, haven't been having good luck with these today. As we see here, I can see that normal is actually intersecting slightly below where those two are. So if you have something like that, you may notice that your angle of incidence and your angle of reflection are slightly off from one another. Not a huge deal if they're pretty close, but if they are really far off from one another, you might want to go back and retry the question. So now I'm just going to come through and I'm going to find my incident or my angle of incidence here, placing that right on top of the point where those are intersecting. I'm going to see that if I were to extend that line back, and sometimes you may need to, right, just in a case like this, I can just kind of quickly extend my incident ray back beyond where the object is, just to make it a little bit easier to use with my protractor and see where that intersects. Now when I put that back on, right, I can see that there is a clear point here where it's going to intersect the protractor, and it's going to be at about 34 degrees. So here, my angle of incidence is going to be 34 degrees. Right? So that there is my angle of incidence. Okay, and then flipping over to the other side, I'm going to do the same process just to make things a little bit easier on myself. I'm going to extend my reflected ray beyond where the eye would be, right? This isn't going to alter the angle whatsoever, right? This is just simply going to make it a little bit easier for me to use my protractor. Now coming in, again, place that right along our normal. Okay, make sure that that part of the 0 is right on that line, right? If you are off, you might notice that there are some slight variances. Now here, it's about 34.5 degrees, right? So pretty close. Some slight error. I'm just going to say 34 degrees just to avoid any confusion, right? And that is my angle of reflection. So again, right, nothing too crazy going on. The curved mirrors might add a little bit more level of complexity, but for right now, really simple problems to solve. Okay, the last one that I do want to cover with you really isn't any different from the question that we did. I just did notice that in all of my sample questions, the eye was below the object. Not really going to change the process at all, but sometimes students have problems when we start flipping things around or maybe move the eye onto the other side. Oftentimes they get a little bit confused as to where to start. So just to kind of show you an example of this type of question, I just wanted to quickly roll through this. So again, using my protractor, lots of different ways that I can go about it. With this one, with the object being so close to the actual mirror itself, I'm going to use the same process I did in the last question. I'm going to flip my protractor over, right? Again, making sure that that 90 degree mark's intersecting and that my point is directly on the line. That is going to give me a perfect perpendicular line to the mirror, all right, 90 degrees. And I'm just going to extend that beyond the mirror itself, right? So again, we're just simply measuring the distance from the object to the mirror, right? So in this situation, I am at 4.1 centimeters from the object to the mirror itself, right? So that is 4.1 centimeters. So with that being said, I am going to go onto the opposite side of the page, right? I'm going to measure 4.1 centimeters back off of that page. And I'm going to see that my object, or my virtual object, is located right here. So that there is, again, my virtual object. Again, remember, right, if we are talking about our objects, right, this is my real image, my real object. This is my virtual image. I really shouldn't say object there because it is an image. It is not actually the object itself. So I'm just going to clarify that. So now when we're working through, right, there is, again, nothing different from what we've seen before, right? We are simply going to take our ruler, again, taking that line, making a nice straight line from our virtual image back to the eye itself. This ruler, right, taking my point, started off on the object itself, or sorry, the image, right, running that back to my eye. Again, solid line on that side of the mirror, dotted line on the back side of the mirror. Okay. Again, remember, draw your arrow. That is your reflected ray. Then you can draw your other line, right, going from the mirror where that reflected ray is going to intersect back to the object. Right, this is our incident ray. And then we need to go through and make our normal. So again, just taking our protractor, right, putting that point right at the point where everything is going to intersect. So those three lines, your incident ray, your reflected ray, and your normal, or sorry, your mirror, right? Find the point where it's going to line right along those, right? And we're going to draw our point at 90 degrees over on this side. Right, be careful when you are measuring these. If you kind of try and speed through your normal, oftentimes it will mess up your overall calculations, your angle of incidence and angle of reflection calculations. So try and take your time, right? Try not to rush through it because a simple mistake right here, maybe drawing that on a 2-degree angle, is going to lead you with pretty confusing results. And maybe I'll show you that right after this, just in case. Right, now I can go through, right, measuring my incident ray. Right, I'm coming down. Again, I run into this problem where the ray is going to be quite far, or sorry, my protractor is quite far beyond the ray. Right, no problem. You can just simply take your ruler, put it onto that ray, make sure it's nice and lined up, and you can just extend that beyond your incident ray as well as beyond your reflected ray. Right, so doesn't really change anything about the diagram itself, right? Just makes it a little bit easier to read. So now when I do that, I again can line up my protractor, 0-degree line running right across my normal. It's going to come out and I'm going to see that this is 47 degrees. Right, so my angle of incidence is going to be 47 degrees. And then assuming that I did everything correct, my angle of reflection should also be 47 degrees. And here, if I look, it is at 47. So that is 47 degrees. Angle of reflection. Make sure you label your normal. And the question is complete. Right, so really nothing too far off here. One thing I do want to show you, and I'll just kind of do this in red just to show you what an error in your normal could look like. If I accidentally maybe draw my normal and it's not perfectly perpendicular, right, I'm going to exaggerate this a little bit. Very rarely would an error be that large? Let's say even I missed by a matter of, let's see how much that is. So there, I missed by 5 degrees, right? So that is a 5-degree difference from where my normal actually should be to where I drew it. Now, if I go through and I calculate my reflected ray and my incident ray, you are going to see a pretty drastic difference. Okay, I have 51 degrees for my angle of reflection, and I have, any of you mathematicians can probably figure out what this one's going to be. I am going to have 43 degrees, right? And that is a pretty drastic difference. That would be deemed incorrect, okay? So just please make sure that you're doing a good job and taking your time when you're drawing those normals, even when you're calculating these distances, because slight variations in the angle can end up being a pretty significant difference in the responses from 47 to 43 or 47 to 51. Okay, so just please make sure that you're taking your time with these ones, right? That being said, I think everybody should be good to go, and I'll maybe do another video for our curved mirrors.